Hey everybody, this is the chapter on perception. I'll do sensation on a separate video. I'm going to do the best I can to emphasize the parts that I think need teaching. If you see an optical illusion that you want to spend time on, hit pause or use the PowerPoint. There's a lot of optical illusions on here, and I don't want to spend too much time on any particular one. Let's get going here, okay? So this chapter is called perception. Now think of the word perceive, okay? To perceive something means to interpret something. So perception is just the noun version of perceive. Perceive is a verb, perception is a noun. And so this optical illusion that you're looking at, you perceive it to be moving. It's not moving. I promise you it's not moving. If you keep your eyes very still, it'll stop moving. Or if you stare at any one specific spot, it will stop moving. But our mind perceives it to be moving. I read somewhere that it has to do with the muscles behind your eyes is what's making this thing move. Okay. Here's another similar optical illusion. It's not moving. You just perceive it to be moving. Okay. So perception is how we perceive or interpret information. Now, the reason I have this picture, this is a band called Milli Vanilli, and they were like a one-hit wonder back in the 80s. And they had a song that was really popular for a while. Well, it turns out that it was a big scam. They lip synced. Not only did they lip sync, but they didn't even sing the song in the studio either. And so it was a big old scam. But the point is that if they get up there and they move their lips and they dance, we perceive them to be singing it. Okay, that's perception. So what is perceptual set? It is we see what we expect to see. Okay, if you expect, like for example, if you're walking around the woods and you expect to see an alligator and you see a log floating in the lake, you might perceive an alligator. That actually happened to me once. That was scary. I thought it was a big old crocodile just because me and a friend were talking about it. It's based on top-down processing, which is another concept that is at the end of this chapter. Top-down processing is when you think of the big picture first, and then you pay attention to the smaller details. So let's imagine this. Let's say I'm going to show you a bunch of pictures. Well, here, first of all, this is a classic illusion. What you see in the middle depends on what you expect to see. If you start on the right, then you may look at this middle picture and perceive a woman's face. But if you start over here on the left, you're more likely, and then you look at the middle picture, you're more likely to perceive a guy playing saxophone. Okay? Our expectations guide our perception. Okay? So here's an interesting little thing. So I'm going to show you a bunch of pictures. I need you to pay attention to the pictures. Put your phone down and look at these pictures. Okay, here we go. Boom. Okay, look at the pictures. Don't think. Look at the pictures. And what do you see? If you don't think about it and you were paying attention, you probably see an old man with glasses. However, if I show you a bunch of these pictures first, and then I show you that same picture as from before, you're more likely to see a mouse or a rat because you see what you expect to see. That's called perceptual set. Okay? Same thing here. What is in the middle? It depends on what you expect to see. You say ABC 12, 13, 14, but the middle is the same thing. You don't see 12B14. You don't see A13C. That's perceptual set. Okay. You like fried chicken? Well, how about this? You see that? You were expecting to see fried chicken, so for an instant you might have perceived fried chicken. You like concerts? Well, you like this? See, that is a cotton field, by the way, and that is a harvester picking cotton at night. Okay. If you want to hit pause and look at this, that's fine, but all of the balls in this picture are brown. They're all the same color. Only the color of the lines that cross the balls change color. It's a freaky illusion. Here's another one. This one really freaks me out. This is a black and white photograph. Only the lines change color. It's crazy. Pause and take a look at that. Now, if you take both A and B are the same shade. If you take your finger and you cover the line, you'll notice that A and B are the same shade. It's crazy stuff, okay? Okay, so a cheetah escaped from a zoo, scrambling up a rocky slope in Montana is likely to be perceived as a mountain lion because what? Well, remember, cheetahs don't live in Montana. You would not expect to see a cheetah in Montana. Hit pause if you need to. The answer is A. Our perception is guided by our expectations. Okay. A widespread increase in the reported sightings of UFOs following newspaper reports of similar sightings may be attributed to what you see, what you expect to see does affect your perception. Okay. I'll go ahead and show you this GIF just so you don't, this is just for fun. Okay. All right. What did you just see? Well, you think it says a bird in the bush, but it doesn't say that. It says a bird in the bush because you expected to see a bird in the bush. It's like your brain's on autopilot. So, what is Gestalt? Gestalt is there. It's not a dead German guy. It is a German word. It is principles of mental perceptual organization. The word means organized whole. And here are 4 of them. There's a few more than that. You got similarity, proximity. Think of the word proximo in Spanish. Proximity is kind of the same thing. It means when you're near something, when 2 things are close together, we associate those things. Similarity, if 2 things are similar, we relate them together. Continuity, we tend to think of this as one continuous line. It's not, but we think of it that way. And closure, I got better examples, but closure is when your mind fills in the blanks. Okay, I'll give you a better example. Check out the bottom right, closure. Look, there's no triangle there. It's just 3 Pac-Mans having a conversation. Similarity, we tend to think of these as columns, not rows. Proximity, we think of these 2 lines as being together, not this line and this line over here. Okay. So take a look at that. Hit pause if you need to. Take a look at that. Hit pause if you need to. Okay. This is an old optical illusion. Both the left and the right of the same picture, except for the black stripe. The reason this optical illusion works is because of which Gestalt principle. Think about it. Well, it could be closure or it could be continuity. Okay, that's why that optical illusion works. Okay, it's called the Poggendorf illusion. It's an old one. Continuity, we think of a whole baby there. We don't think of a chopped up baby there. And look at that. There's no triangle on there. There's no star up there. It's just Pac-Mans and V's. There's no star or triangle up there. Which Gestalt principle is that makes you fill in the blank? That's closure. Closure. So we tend to think of that as columns, not rows. We tend to think of that as rows, not columns, because of similarity. Proximity. We tend to think of that as columns, not rows. But we tend to think of that as rows, not columns, because when two things are close together, then we associate those things. Think about like when a teacher just assumes that you're best friends with the person you sit next to. And you're like, teacher, I don't know the guy, I just sit next to him. Okay? Closure. So the fact that objects that are near each other tend to be grouped together is known as, the answer is proximity. The ability to see a cube in the diagram above is best explained by which of the following? Hit pause if you need to. The answer is B. Closure, nearness, similarity, and continuation are categories of, the answer is A. Remember to hit pause when you need to. The Gestalt principle that refers to an individual's tendency to perceive an incomplete figure as whole is called what? Okay, so you're filling in the blanks. The answer is closure. The tendency of most people to identify a three-sided figure as a triangle, even when one of its sides is incomplete, is the result of a perceptual process known as, the answer is A. Figure-ground relationship. When you think of ground in this case, I want you to think of the word background. And when you think of figure, I want you to think of what is in front. So you got what's in the front, and then you got what's in the background. And you get what's called reversible figures. This thing that you're looking at here is a reversible figure because in your mind, you can take the black and put that as the figure. And if you put the black as the figure, then you'll see a vase. But if you put the black as the ground and the white as the figure, then you'll see two faces coming together. That's called a reversible figure. You can reverse the figure and the ground. Okay. Here's another one, except it's a goblet instead. You got faces, and you got goblet, and you can switch them. That's why it's called a reversible figure. Camouflage works because of our inability to distinguish figure from ground. That's why camouflage works. That's why, I mean, imagine you're in an airplane and you're looking for a green tank to shoot. If it's green and there's a lot of green around it, it's going to be a lot harder to see. Okay. What do you see? Well, if you put the white as the figure and the black as the ground, you'll see that it says lift. Okay. So what is a figure ground? I don't know if this definition works too well, but you've got figure is what's in the front and the background is what's in the back. Okay. Here's another reversible figure. I'm going to move on, but you might see a young lady looking away, or you might see an old woman, and you can reverse them. Okay. Read this out loud. Go ahead and hit pause and read it out loud. The reason you can do that so easily is because of not only top-down processing, but you're looking at the whole word. You're looking at the whole word. Here's another one. You can read this because you're looking at the whole word, not just the individual letters. The reversible figure above illustrates the Gestalt organizing principle of, and the answer is B. This is an interesting question. While attending a concert, Carl finds that he can clearly recognize the melody coming from the lead violin above all the other instruments playing in the orchestra, even though the other instruments may be louder. You could call that selective attention, but that's a different thing. Gestalt psychologists would explain Carl's ability using the principle of, and the answer is figure ground. Think of the violin as the figure and the rest of the orchestra as the ground. In psychology, Gestalt principles are used to explain. The answer is C. Remember to hit pause so I don't ruin it for you. All right. So remember the difference between a hallucination and illusion. A hallucination is when you see something that doesn't exist. An illusion is when your perceptions are altered. So I don't want to spend a lot of time on any one optical illusion, but if you want to hit pause, go for it. Spacebar is usually pause. These are illusions. That's a GIF. Once you take away those little white dots, then the lines straighten up. It's really weird. But look how curved the lines look. But then when you vacuum up all that other stuff, then it changes. Strange stuff. Same thing here. That line, those lines are perfectly straight. They're not wavy at all. Strange. That is not moving. Neither is that. Those are not moving. Let's talk about depth perception. If you're into computer and art, you might like this stuff. Before we get into more detail, I want to tell you about Eleanor Gibson. Eleanor Gibson studied depth perception in infants who knew how to crawl. And she set up this thing where this was made of glass, very clean glass. So the baby was totally safe. But the mom would come stand over here and say, "Come to mama, come to mama." And if the baby is really young, the baby might come to mama, which would indicate that the baby doesn't have depth perception. But after about a month, after they're about 6 weeks old, the baby's like, "No, I'm not coming to you, mama. I might fall and hurt myself." So this was an experiment done by Eleanor Gibson, and she found that depth perception is innate. You need to know that word. It means inborn. It means it's nature, not nurture. Okay. So experiments with the visual cliff show that. Hit pause. The answer is actually it's D. It's actually D. Eleanor Gibson and Richard Walk used a visual cliff with a glass cover drop-off to examine behavior in crawling infants. Even when coaxed, come on, by their mothers to crawl out onto the glass covering, most infants refused to do so, indicating that they had developed depth perception. Okay. So how do we perceive depth? There are binocular cues. Bi means two. Okay. Bi means two, like a bicycle has two wheels. Monocular cues have one. Okay, one eye. So if you only have one eye, you can do a monocular cue. Think of a monotheistic religion, one God, mono. Monocle, one eye. So let's talk about binocular cues. There is convergence, which basically means this. If a bug is flying around close to your face, you can cross your eyes a little bit, and the more you cross your eyes, the closer you perceive the bug to be, or whatever it is you're looking at. That's called convergence. Retinal disparity, think retina as the back of your eye. That's retina. Retinal disparity means different. So your left and your right eye see two different things. Hold up your finger, close one eye, and then close the other. Don't move your hand. And what you'll find is when you close one eye and open the other, then your finger shifts. That tells you that your left and your right eye see different things. And somehow your mind uses that to determine depth. So the ability to identify the direction from which a sound originates is strongly dependent on having two ears separated in space by several inches. So what hits this ear is also going to hit this ear like a tenth of a second later. And your brain knows that and does the math and says, oh, this ear got the sound sooner, so that means the sound is coming from that way. That's called sound localization. That is similar to retinal disparity. So what if you only have one eye? Okay, let's say you only have one eye. You can't do retinal disparity. You can't do convergence. But there is a lot that you can do. Monocular cues. There's a lot on here. There's called interposition, which means that if I am blocking your view of something behind me, then you know that I am closer than whatever's behind me. You can call that overlap. Relative size. If we know that two objects are about the same size and one is smaller, then we know that the smaller one is further away. Basically, all this stuff up here pretty much all mean the same thing. Texture gradient, relative clarity, visual acuity. So if you're looking at a picture or a painting, it's going to be more clear closer up and more fuzzy further away. Relative height. On a picture, when things are higher, that means they're further away. Motion parallax. If you're on a train or on a car, then the closer something is, the faster it's going to appear to move. I got a better video for you on another slide, but we call that motion parallax. Linear perspective, think about railroad tracks coming together in the distance. They converge. And light and shadow. That's easier to show you than it is to explain. So linear perspective. We think about why we perceive that top yellow line is to be bigger, because we think of lines converging, come together in a distance. We perceive that top yellow line to be further away. So given the same retinal images, our mind assumes that the top one is further away. We assume that those young men are just far away. We don't assume that they're small. Relative size. Interposition. Think about, why does this dog appear to jump out? Because the dog is blocking your view of the white lines. It's also blocking your view of other things. So we perceive this dog to be jumping out. We call that interposition, overlap. Why is it so hard to determine which one of these buildings is closer? The reason why is because it's hard to do interposition. It's hard to see which one is blocking which. Linear perspective, the lines are converging in a distance. Okay. The lily pads at the bottom you see more detail, so that's texture gradient and relative clarity, visual acuity, you see more detail at the bottom. At the top, you don't see that kind of detail. Motion parallax. So notice the stuff that's closer is moving faster and the stuff that's in the distance is moving slower. We call that motion parallax. Light and shadow. That blue square is not moving at all, but the shadow is. So we perceive that blue square to be coming at us. Same thing with these balls here. The balls don't move from A to B, but the shadow does move. So you could, if you're an artist, you could do a lot with light and shadow. Which are bumps, which are holes. It depends on the shadow. What's really interesting about this is that if you take this and flip it upside down, the bumps become holes and the holes become bumps. It's really weird. You can't see this because I'm in the way. But if you use light and shadow, you can give depth. In making a charcoal pencil drawing, which pictorial depth cue could you most effectively use with just a charcoal pencil? Light and shadow. Which balloon is closer? The bottom one, because of interposition. It's blocking the view. Okay. Which monocular depth cue is illustrated in the figure above? The answer is E. When viewed from the window of a moving train, nearby objects seem to pass by more quickly than do more distant objects. This cue for depth perception is called motion parallax. JoJo injured her eye in an accident and has to wear a patch over the eye while it heals. Which of the following cues would she best be able to use to make judgments about the distance objects are from her? So in other words, which one is a monocular depth cue? The answer is C. E, D, and E, those are not depth cues. Those are Gestalt principles of organization. A and B, you got to have two eyes to do those. If you stand in the middle of a cobblestone street, kind of like this right here, the street will look coarse near your feet and finer if you look into the distance. Coarse, finer. That's called texture gradient. I've never seen that on the AP exam. All right, the phi phenomenon. I don't know if it's phi or phi. I think it's phi. It's an illusion of movement created when two or more adjacent, meaning next to, lights blink on and off in succession. So imagine you're at a railroad crossing and you got blink, 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 and you get this left and right motion. Okay. Or Christmas lights or marquees on a movie theater. So when a pair of lights flashing in quick succession seems to an observer to be one light moving from place to place, that's the phi phenomenon. Shape constancy. So if you look at a door, you can see that it's a rectangle. But if you look at a door that's partially open, you still perceive it as a rectangle, even though that the image on your eye is technically a trapezoid. But your mind keeps it constant. So the size is constant, even though the image on your eye changes. Size constancy is the same thing. If a dog runs away from you, you don't think of the dog as getting smaller. This is not a good picture to go with this concept. But the point is that when a car is driving away from you or a dog is running away from you, you don't think of the car as getting smaller. You observe two cars of identical make and model, like two Toyota Corollas. Although one roars away from you and its image on your retina is changed, you still perceive the cars as identical. This phenomenon is size constancy. You don't think of the cars as getting smaller because they drive away from you. In visual perception, size constancy occurs as an object comes closer to the viewer because the hit pause and really think about this question. All right, so go with the answer, the only answer that is true. And the answer is D. The answer is D. Okay. The film Star Wars created illusions of death by quickly changing images of the sizes of planets and starships using the pictorial depth cue called relative size. So if they want to drive away from a planet, they'll just make the planet smaller. As you watch a friend walk away from you, as my friends have always done, your retinal image of your friend gets smaller. Despite this, you do not perceive him or her to be shrinking. This is an example of size constancy. I've never seen this on the AP exam, but the Mullerlyer illusion, it doesn't work with people who grew up in round buildings, like a yurt in Mongolia or something. It works in people who have grown up in square buildings. The reason why it works the figure on the left seems to be closer since it looks like an outside corner thrust towards you, whereas the figure on the right looks like an inside corner thrust away from you. Given retinal images of the same length, you assume that the closer line is shorter. I don't really get it myself. This is called the Ames room. I've never seen this on the AP exam, but it warps your perception. The person on the right is actually closer to you, but it just messes with your eyes. Okay, let's talk about context effects. True or false, the orange circles are the same size. True, they are the same size, but the context is different, which makes you perceive one is bigger than the other. Now think about this. Why do restaurants like to use big plates, but buffets like to use small plates? Because restaurants and buffets have opposite purposes. Buffets want you to eat less. Restaurants want you to order more food. So if they give you food on a big plate, then psychologically you'll feel like you're less full. So your ventromedial hypothalamus isn't quite kicking in. So here's another hint. If you ever are trying to lose weight, eat on small plates because you will be satisfied mentally with less food if you eat on saucers and not on plates. Everything has context. So we always think of Shaq as being one of the biggest people in the world, but look at him next to Yao Ming, right? So everything has context. True or false, both center patches are the same shade of gray. That is a true statement. Okay. This illusion really messes with my mind. Perception is a process by which sensations are assembled into meaningful patterns that represent external events. That's a wordy answer. Okay. All right. Now let's talk about top-down processing versus bottom-up processing. Top-down is when you see the big picture first and then the details, the forest and then the trees. Bottom-up is when you see the small details, then the big picture. So let's take a look here. Top down, at first you see a wilderness and you see some horses, but hit pause and then you're going to see a whole lot of faces jump out of there. Top down, at first you see former President Bush, but then you realize that this is made up of faces of young men and women who died in the Iraq War. There is a dog in there somewhere. Okay. Top down, at first you see a guy, then you see all kinds of details. So hit pause and take a look at that for a while. Top-down processing. Everything on here is Snoop Dogg. Okay. At first you see the face, but then you see the word. And if you can't read cursive, then this won't work for you, but it says liar. Bottom-up processing, it's better if I show it to you. So check this out. So it starts off as pills, but then when you back up, and then you see something else. That's bottom-up processing. Bottom-up is when you start with the minor details and then look at the big picture. You were shown a picture of your grandfather's face, but the eyes and mouth are blocked out. You still recognize it as a picture of your grandfather. So you're looking at the big picture. That's grandpa, okay? You're not looking at the individual details first. You're looking at the big picture first. So we call that top-down processing. Shaniqua, a math major, sees the drawing above as a Venn diagram. Her brother, an art major, sees it as two circles. The difference in perception is an example of what? This is also like perceptual set. You know, you see what you expect to see, okay? And that is also based on top-down processing. Juan is reading an important letter when he accidentally splashes water on the paper. The water has smudged a few words, but he is still able to understand what the letter says. Just like earlier with the Gestalt reading, if you can read this, you're smart. It's based on top-down processing. Okay. All right, so we're halfway done with sensation and perception, which is 6 to 8% of the multiple choice on the AP exam.